Moz Alnori, who would be walking us through their experience on network security monitoring built on top of Elastic. So they are doing an awesome security consultant service around network security monitoring, and they would like to share their experience with explanation and demos. So I am Haran Kumar, security specialist here at Elastic. So I would be co-hosting along with Mouse. Please feel free to share your questions in chat or Q&A box. Also at the end, we'll open the forum for live Q&A as well. So over to you, Mouse. Thank you.
Thank you so much, Haran. Hello and good morning, all. I think all of us are in the APAC region, so it's morning for all of us. So good morning, all. And thank you for joining this webinar. It's definitely a pleasure to be here, and I appreciate the time you spared to attend this one. I hope you find it useful. So I'll be sharing my screen and I'll go to the presentation mode. So Haran, I believe by now that you are seeing the slides in presentation mode. If no, please let me know.
Yes, all good. Thank you.
Thank you. So my name is Mawaz Al-Nouri, and as Haran mentioned, I am the founder and managing director of Skilled Fields. I am a technologist, and I'm coming from a strong technical background. My background is coming from a telecommunication industry, and this is where I was introduced first to Elastic. I still remember the days when we were using Elastic in order to produce some reporting on short messaging service centers and SMS anti-spams and so on. This is where I fall in love with Elastic as a technologies, and I carried it forward with me when I shifted a little bit from the telecom to IT, and then in the IT I specialized in big data, and out of the big data now we are specializing into cybersecurity. So as you can see, I am a lifetime learner, keep learning, and I think it's for all of us. So as I mentioned, I am very fortunate and humbled to be leading a company called Skilled Fields. So a little bit about us: we are a field of skilled professionals. Think about it like any gold field of gold. Skilled Field is a field filled with skilled professionals, and I am very lucky to have these professionals working with me at Skilled Fields. What we do, we solve complex problems with simplified solutions. So we like to keep things simple, and we like complex challenges, and we like to have the complex challenges and resolve them with simple solutions. The areas we work on, we work with the security operations. So we help organizations uplift their cybersecurity detection and response capabilities. Of course, using Elastic products, we deploy centralized SIEM, endpoint protections, machine learning, as well as other partners. We do SOAR services, security automation services. We also uplift the IT operations observability capability. Also using Elastic, we help organizations deploying centralized operational events management, AI ops. Also using our big data analytics experience, we use it in order to provide the operations teams with the insights they want in order to take informed decisions. So as you can see, we're coming from a big data experience, and we are using our big data experience into the cybersecurity area, as well as the IT operations area. We are Elastic Premium Partner, and we are very fortunate and lucky to be partners with such a great technology company. Our areas of expertise around Elastic Stacks, we are specialized into the cybersecurity use case as well as the observability use case. We are experts into Elastic cluster design and build, helping you tune, upgrade, migrate, all the customizations you want to do on Elastic, whether it's building dashboards, building parsers, building watchers, building machine learning, Kibana plugins. These are the areas that we can help you around with Elastic Stacks. Enough talk about me and the company. Let's jump into the topic now. So what are we going to cover today? Today, we are going to cover a little bit about what's network security monitoring. I know that most of you know what it is. However, it's a very good introduction so all of us can be on the same page and use the same terminologies. We're going to classify and talk a little bit about network data, and then we're going to talk about the network security monitoring common tools. And then what are the challenges with network security monitoring? How are we going to use machine learning for network security monitoring? And then a demo using Elastic and how Elastic features can help us address those challenges. So let's start by what is network security monitoring. So network security monitoring, it consists from three words: network security monitoring. So the network is collecting the network data. So monitoring is collection and analysis, and security to identify intrusions. So network security monitoring is the collection and analysis of network data in order to identify intrusions. So that's what's network security monitoring. Now, why it is important? Network security monitoring is very important because network traffic doesn't lie. Now, if you want to do monitoring, you can monitor on the endpoints, you can have IPS IDs. There are lots of controls that they are all important. However, if you have an endpoint that has been compromised, there is a possibility as well that the information this endpoint is telling you has also been compromised. With the network security, with the network data, yes, advisories try to hide their footprints in the network data. However, they can't do that. They must leave some footprints. They can hide them, but they cannot remove them completely. So regardless of how advanced the advisories are, they need at the end of the day to connect to the internet. They need to use the network in order to reach out to other hosts when they are doing lateral movements or so on. So they will definitely leave footprints, and these footprints they can hide, but they cannot delete. It has to be there. So the network data, the beauty about the network data is that it doesn't lie, and it's a place where advisories, whenever they are doing something suspicious, they are definitely leaving footprints. So this is why it is important. So network security monitoring is to collect those network data in order to identify intrusions. And why this network data is important is because the network data doesn't lie. The network data will always have some sort of a footprint for the advisories when they perform malicious activities. Now, when we talk about network data, what do we mean by network data? Network data can be classified in two main categories. One of them is network flows. Network flows, those information, this data provides you with a high-level contextual information about the communications in the network. Things like host, source IP address, destination IP address, source port, destination port. These are all metadata information, and these are called network flows. While the other type of network data is the PCAP. The PCAP is the full packet capture. What it does is that you actually capture every bit and byte in the network, or in the network interface or the network appliance. You capture every bit and byte, and then you analyze. So it's 100% of what's happening on the network traffic. So just imagine on how big would the full packet capture be. Normally it's huge. You can't keep it for a long time. You keep it the full packet capture for a month, 2 months, 3 months maximum. The network flows are the metadata informations, and they are very important in order to do initial investigation, initial analysis. When you want to do further analysis, you jump into the full PCAP capture. Now, the question we are being asked normally is that, do we need the full packet capture all the network flows? Now, this is where we tell it's not or, it's actually and. You need the network flows in order, as I said, to look at the metadata information in order to identify malicious activities, in order to produce alerts. And then when you need to do a further analysis, you jump on the PCAP information. That's why with the network flows, it's data that's required to be kept for a long time, while with the full packet capture, we need it for shorter time. And this makes sense as well because network flows data is much smaller than the full packet capture data. So these two important data are important. We need them both. So that's one of the first challenges that we will be addressing later on. Now, if we want to talk about the network security monitoring common tool sets, now these are some of the common tool sets that are used for network security monitoring. And I'm focusing a lot on the open source technologies and the technologies that have a free version, because the message I want to tell you, everyone, is that network security monitoring doesn't have to be complex. It doesn't have to be expensive. You can use all those tools in order to perform a very well network security monitoring. So when we talk about network security monitoring toolsets, so Snort and Suricata, these two are very common tools used for IPS and IDS, intrusion prevention and intrusion detection. The difference between Snort and Suricata, Suricata works on signature, so it looks at the traffic signature and detects malicious activities. Snort is more rule-based. Another difference is Snort has a very strong community and there are many rules available. in the community for deployment. Suricata does have a community. It's not as big as the Snort community. However, the good thing about Suricata is that it's multi-threading. So, which means that if you have a box, you will maximize the usage of the resources on this box, versus Snort is a single threaded. Each one of them has pros and cons, and each one of them can be used depending on your use case. I'm not saying use Snort or Suricata, you can use both. And that's one of the challenges that we will be addressing shortly with the way forward. So there are multiple use case tools, and they are all useful. We might need them all, or multiple of them. The other one is Zeek. Zeek is a very, it's a great tool. It's a great traffic analyzer. It monitors network metadata and produce logs. So Zeek is a network monitoring, it's a network monitoring tool that produces metadata. Archime is a network monitoring tool that produces the full packet capture. So Snort and Suricata, they are alerts generation. So they look at what is going on, and based on signatures or rules, they trigger alerts. Zeek is used to capture the metadata. Archime is used to capture the full packet capture. Bucketbeat is the elastic network security monitoring agent. It's a very lightweight agent that you can install on the endpoint itself to connect, to collect network security data from the endpoint itself. So how do all these tools work together? So remember, we talked about alerts. So this is alerts. When an alert is generated by Suricata or by Snort, you jump on the network flows in order to do further analysis. This is where you can look at Zeek, for example, in order to look at, all right, I want to look at Zeek in order to have a holistic view and see how the network was flowing during the issue itself. Now, you looked at this, and then you identify that there is this node that have generated this malicious network flows, and I want to jump on the node. This is where I look at the endpoint telemetry data. This is where Bucketbeat, if it's installed on the host itself, it will support the network flows information generated from the Zeek, and then you will have more information on the endpoint. So think about it, you are drilling down, you are coming closer to where the issue is. So the endpoint telemetry data will provide you with information as well. If you are collecting other information like the OS, the events that's happening, the processes, etc. So the endpoint telemetry data will help you doing further investigation on the endpoint itself. The PCAP will provide you every bit and byte that's happening, that's going on in the network. So these tools work together, and there is no one solution fits all. There's no one solution that can provide me with everything I want. If I want a BCAP, yes, I want a BCAP, but I can't keep it for a long time, and I can't deploy it every place in the networks. This is where we need a mix of all. We need systems or solutions that performs IPS, IDS, maybe behind the router at certain points in the networks. We need the nodes that collects the network flows from all the network areas. This is where we use tools like Zeek. We need to collect the network flows from the endpoints themselves. This is where we look at Bucketbeat. We need as well to have, for the worst case scenario or the deep investigation and forensic analysis, we need to have the PCAP information, and this is where Archime fits in the picture. So there are multiple tools needs to be used, and they are all good tools. They all have different use cases, and yeah, our message is, we will always support you that technologies are technologies, tools are tools. These are only examples. I'm not promoting those tools. These are not only examples. If you have different tools, you need to make sure that they work together with the other tools in order to provide you with that holistic view. The biggest challenge with having multiple tools is that now I have multiple data points. I have multiple data sources. I have multiple points to investigate and troubleshoot. It is very important to be able to correlate those informations between the different tools. Now, there are how to do that. Now, to overcome those correlation challenges, you need to make sure that you're selecting a tool that supports something called community ID. Community ID and flow. Community ID is a flow hashing standard. The community ID aims to simplify the correlation between those tools. The community ID is a new project. It's supported by multiple technology vendors, including Elastic, also MISP, Archime, Suricata, Zeek. They all support that correlation ID. So once you are having your network security monitoring with multiple nodes distributed everywhere, you need to make sure that you're using tools supporting that correlation community ID in order for correlation, or another community or another correlation method that you need to make sure that you can easily look at the overall picture using a correlation method. So we mentioned that there are multiple tools, and all these tools we need to be able to correlate it, and we need to be able to view the different informations coming from different ways. So where should we be looking at those informations? Do I need to jump on the Suricata, look at its logs, jump on the Snort, look at its logs, Zeek, look at its logs, use that correlation ID to correlate the information? The answer is no. This is where SIEM fits in the picture. SIEM is Security Event Information Management. This is where you need to make sure as well that the tools are integrated with the SIEM, and your SIEM supports those tools. Your SIEM supports all these majority of tools, that it can get the tools. It supports a standard data schema. It supports a correlation between those two environments. The SIEM will provide you with a single pane of glass that will allow you to look at the data generated from those different network security monitoring tools, as well as correlate it and produce insights and good information out of it. So another challenge we want a centralized architecture. We want to be able to get the logs from all those network security monitoring into a centralized environment. That's the SIEM. So let's talk about next thing. Now, the other value that the network security monitoring provide is the ability to implement machine learning techniques on top of it. Let me explain this for a bit. What I mentioned earlier is that network security data doesn't lie, right? There's always footprint for something that's happening in the network. So when something malicious is happening, there's definitely a footprint, because advisories have to use the data, right? If we are using IPS IDS with the latest updated rules, with the latest updated whitelist, blacklist, with the latest updated signatures, they will only get the malicious activities that are known, that has been used somewhere else. But once you have a crafted malware that's specifically targeting your organizations, this is where those techniques might not detect those activities. And this is where you need to use machine learning in order to monitor the network data and identify the malicious behavior, malicious activities. What is that called? This is called an indicator of behavior. For people who work in security, they will be very familiar with indicator of compromise. Indicator of compromise, it's something, if you see in your network or in your environment, it means that you have been compromised. So if you see a connection with a malicious website, it means that, or why, it means that there could be a malware that's communicating with that malicious website. If you see a communication with a malicious IP, it could be a command and control server. If you see a virus with a negative hash sent in the email, it means that. So these are indicator of compromise. Now, in the machine learning world, we use something called indicator of behavior. Indicator of behavior, it's something that indicates that there's something malicious happening. What it is, I don't know. So the machine learning job wouldn't give you the end answer. It will tell you that this behavior is indicating malicious activities. It could be this, but what exactly is happening, who is exactly generating these informations, you need to dig deeper. And this is where the machine learning complement the network security monitoring. So using machine learning, we will get indicator of behavior. We will use the Zeek information, the network flows, the PCAP information, the node telemetry data in order to do further investigations and identify early enough malicious activities. Within machine learnings, there are always two types of machine learnings. I like always to highlight those two types. There are supervised and there are unsupervised machine learning. With the unsupervised means that the machine learning learns from the historical data. With the supervised, you give the machine learning reference data, and then it applies classification regressions to learn from these classified data. Why I like to put these slides, because lots of people think that once you tell them machine learning, all right, if you want me to do machine learning, it means I need to keep 3 months or 1 year of data so your machine learning job will learn. Actually, that's not true. You don't need, well, if you have, that's also perfect, right? Because we will have enough data to learn from it. However, if you turn on the machine learning job today with no historical data, it will start learning. And the more it learns, it will improve the results. So don't worry about having too much historical data before you run machine learning jobs. If you have a machine learning capability, deploy it and start it as soon as possible, because if you don't start learning, you're losing opportunities to identify normal behaviors and then trigger anomalies. So the way we do it normally, we turn on the machine learning job, run it for a week, 2 weeks, 3 weeks, a month, review the results. Once you're satisfied that the machine learning job has learned enough from the behaviors, then you can ignore, then you can put it in production and start looking at those alerts generated from the machine learning job. So machine learning doesn't have to be complex. Again, machine learning can be simple. You can turn it on as soon as you can. One of my best preferred mottos is that the best time to plant a seed is today. So don't wait until you have enough historical data and then run machine learning jobs. If you have that capability, turn it on today, make the machine learn from the data. Otherwise, you're losing this opportunity to learn. Let's talk about some examples of the machine learning and how does it work. DNS tunneling. I'll explain a little bit about DNS tunneling. DNS tunneling happens when adversaries, what they do is that they use the DNS protocol in order to exfiltrate data or actually communicate with command and control server. So the packet will be in the packet shape of a DNS, so it will has all the DNS protocol information, and the payload will actually have your actual data being exported, or the payload will have actually commands in order to communicate with the command and control server. So that's the DNS tunneling. If you look at MITRE framework, MITRE attack framework, if you look at this technique, you will find out information about how to defend yourself against DNS tunneling. So what they say is that you need to filter network traffic. So you need to have a proxy or a firewall that looks at your traffic and filter out the traffic based on a whitelist, blacklist, based on whitelist, blacklist listing function, you can filter your traffic. So that's one way to protect from the DNS tunneling. Another way is IDS, Network Intrusion Detection and Prevention System. This can look at rules. This could look at signatures as well and identify that this is not a real DNS, or this DNS, we know that it's malicious because we've seen it somewhere else. So we are blocking, or they are generating alerts that an intrusion has been detected. Now, these are very important. These are very important controls. You need to have them. You must have them. However, again, what if this attack is tailored to you? What if this attack is a new attack that hasn't been yet populated in your whitelist, blacklist provider or in your IDS, IPS provider? This is where the machine learning helps. One of the machine learning jobs we can or can be created is a machine learning job that detects unusually large number of DNS queries for a single top-level DNS domain. So what the machine learning looks to look at the number of DNS queries per target domain, top domain. The top domain is, for example, skilledfield.com.au. That's the top domain. If we have whitepaper.skilledfield.com, the top domain is skilledfield.com.au. So sorry, it's the .com. So it looks at the top domain and then identify that there has been an unusual large number of DNS queries to that top domain. You can have a top domain, second domain, depending on your use case, but that's one of the examples of the machine learning use cases. The other one that I like is unusual network destination and domain name. So how it works is that in this one, you have a malware or you have a malicious actor in your networks. And what they do is that they communicate with an uncommon DNS name. This is an unusual DNS query, not unusual. So the previous one, we're looking at the number of DNS queries per domain name and identify when there are a large number of DNS queries sent to a particular host or the DNS domain question name. In this one, we are looking at that. This is the list of the DNS normally being used by in this network by the employees of this network, and then it will detect if there has been an unusual DNS query or DNS name being set. Now, this might generate, and people might tell me that, all right, but this might generate too many events because people visit new websites all the time. That's absolutely right. This is where you need to complement when a machine learning triggers an alert. This is where you need to complement it with a SOAR, where a SOAR, so once the malicious is being detected, this is where you can automate a SOAR or automation in order to look at the domain name, identify if it's malicious or not, and if it's not, then you can close the incident. If yes, you can then escalate to the security analyst and ask them to act on it. So that's another example for a machine learning job. Also, the machine learning job, guys, can always be tuned. So there's always tuning parameters where you can say if it's like one domain name, like one DNS request or 10 DNS requests or 100 DNS requests, don't worry about it. Once it becomes a higher number of DNS queries, and then raise an alert. So the machine learning job can always be tuned. Unusual web requests. This is my favorite machine learning job because lots of organizations deal with a supply chain provider. And we all know that supply chain is becoming very important. So you need to make sure that your subcontractors are doing the right thing. So if you are an organization that has a subcontractor and you normally log into their website in order to place an order, register a deal, update details, whatever it is, then their domain name will always be in the whitelist, right? What the machine learning can do as well, it can look at the URL for that domain and identify unusual URLs. Why is this important? Because if your subcontractor has been compromised and their supply chain, and we did hear lots of recent incidents related to supply chain. If their website has been compromised and then you download or you access the website and it directs you to a malicious, unusual URL, this is where the machine learning job can detect that I have been redirected to unusual URL for this whitelisted domain. Again, it can be tuned and you can identify the level at which you check the domain names. So that's 3 examples about the machine learning. Now, let me tell you about our demo environments and support environments. I'll tell you a little bit about how are we using different techniques in order to overcome those challenges. So the heart of our solution is Elastic Stack. And a quick talk a little bit about the Elastic Stack. So the reason why we call it Elastic Stack is because Elastic Stack provides us with these 3 layers. So the first layer is the data ingestion and the data collection layer. These are the beats, endpoints, and Logstash. I'll come back to this. So the first one is the data ingestion. The second one is the data store and analysis. And Kibana is the visualization, is the window towards Elasticsearch. So everything happens in the Elasticsearch. Elasticsearch is the heart of the stack, and it is where we store the data. And you will use Kibana in order to query Elasticsearch and analyze the data. Kibana is the eyes, is the visualization that provides, is the eyes towards Elasticsearch. So this is where we build dashboards. This is where we run the commands that are being executed on Elasticsearch, but this is where we send the commands. And as I said, Elasticsearch is the heart of the stack, and it stores the data. Beats, endpoints, Logstash are powerful tools that are used in order to collect data. Logstash is an ETL tool. You can write your own custom code in order to process the data by any way you want. The beauty about Elasticsearch is that it provides you with this layer, with this Logstash, and the ability to customize it in order to collect any logs you want. So say, for example, that you are using an IDS IPS commercial tool where beats and endpoints doesn't have a way to process the logs and ingest them into Elasticsearch. This is where you can write your own code in order to break down the log messages or those events into key value pairs and ingest them into Elasticsearch. So think about Logstash as a very powerful ETL tool, extract, transfer, transform, and load tool that's used in order to get the data from any source to put it into Elasticsearch, and then you can search it and analyze it using Kibana. Beats are lightweight agents that can be installed on any endpoints, and they come with predefined modules. Their modules library is massive. Every time I need to, I think that this is a complex solution, I need to write log/slash code for it, I found out that there's Beats model for it. So Beats models are massive, and they're lightweight agents used specifically to collect data, and they have predefined modules. They collect the data from the data source and ingest them into Elasticsearch. The third one is the endpoint. This is Elastic Endpoint or Elastic Agent. This is where we can collect security events and perform security detection and response on the endpoint itself. So this is why it's called Elastic Stack. Elastic Stacks because it has those three layers, a data ingestion and collection layer. And I will show you shortly how did we use it in our actual environment. So data collection layer, data store and analysis layer, and well, analysis data store layer, and Kibana is the analysis analytics tool. It's a tool. It's the window towards Elasticsearch. So this is the stack. Elasticsearch. Elastic is a search company. So once you have the data in Elasticsearch, this enables you to search the data at a speed and also store it for a long time. So Elasticsearch has the ability to have hot, cold, and warm, and now frozen tiers in order to store your data for a long time. So the network flows, for example, you can, and also the packet captures, the bcap files for the past 1 week, you can store them on hot, and then move them to warm, and then move them to cold, and then move into frozen. Frozen is actually nothing but a very cheap S3 or blob, an object storage where you can store the data there. And even if you are storing it there, you can still search it. So that's Elasticsearch provides you with a great ability to store the data, all right? Store the data and keep it for a long time, yet being able to search it very quickly and get results in seconds. So that's Elasticsearch. Now, so this is why it's the stack, and this is the value of Elasticsearch. The other thing I want to talk about is that the Elastic Stack you can use it for any use case. As I mentioned at the beginning, I remember we used to use Elasticsearch in order to do analysis for the short messaging service center CDRs. CDRs are called call data records. So we used to get those call data records and analyze them into Elasticsearch in order to get a success rate of how many messages per second being sent, etc. So Elasticsearch can be used pretty much for any use case you have, as long as you want to search your data. Now, Elastic identified few top use cases, and these are enterprise search, Elastic observability, Elastic security. And they have developed a solution on top of the Elastic Stack. It's a ready to deploy solution. That's where I'm telling you guys, network security monitoring doesn't have to be complex. It can be simple. So you can get the beads in order to collect the data, and then you can use Elastic Security in order to perform security monitoring. So that's all existing today in Elastic as a product. Elastic Observability is used for operation and monitoring. Elastic Enterprise Search used to enable your employees to do enterprise search on enterprise data. Elastic Stack can be deployed anywhere. You can have it as an Elastic Cloud, as a SaaS offering. You can have it a self-managed Elastic Stack, so you can deploy VMs, install the stack, and manage it. If you want to get that, if you want to have a middle ground, like I still want to manage it, but also I want the SaaS offering, you can get Elastic Orchestrators. There are two versions of the orchestrators. There's Elastic Cloud Kubernetes and Elastic Cloud Enterprise. So in our solution for network security monitoring, we will be using Elastic Stack. Elastic Stacks, because of those three layers, Elastic is a search tool. It can be used for any use cases. However, we are using it today for Elastic security. Elastic can be deployed anywhere, whether on-premise, in the cloud. Those are the two options, on-premises or in the clouds. It can be deployed whether you want to self-manage it or use Elastic orchestration. There are huge deployment options. Remember, I talked to you about that we need to use a tool that helps us sense the data to a centralized environment and also be able to correlate the data. This is where Elastic have, with the Elastic Beats, they parse the data against a common schema called Elastic Common Schema. So which means that even if you are using your own log/stash code and use it in order to collect your specific tool network security data, you need to parse it against elastic common schema. And if you do this, you will be able to correlate the data across the other tools. So Elastic provides you with Elastic common schema. I highly recommend for anyone who's using Elastic to look at it. It's available on GitHub. It's open. It's for all of you to use. If you want guys to build your own custom parsers and custom logs collections from your own network security monitoring tool, make sure that you stick to Elastic common schema, because when you do this, you will be able to correlate the data coming from multiple sources. And because of this Elastic common schema, this is where we can correlate data from multiple data sources, as I will show you shortly in the demo. I'll move a little bit faster, I'm cautious of time. In terms of architecture, in terms of the architecture of our demo, so what we do, we have one box. We have one box where we install Zeek, Snort, and Suricata. But if you want to talk about deployments, normally in network you have switches. So what you need to do, you need to have a mirrored link. You need to mirror the link, and then you use a network broker in order to break the network towards multiple network monitoring appliances. So think about this. When you are collecting the network metadata, you install Zeek on a hardware. Now that hardware can have a 10 gig link or 1 gig link, right? Let's say that you have a 10 gig link, you're mirroring it, and you want to watch. How do we break this down? So the 10 gig links, you send it to a network broker, and then the network broker break it into 10 1 gig links if you have 10 Zeek boxes. Those Zeek boxes will act in a cluster way, and they will collect the metadata information. You install FileBeat on the same box. FileBeat will look at the Zeek data, will collect the Zeek data, will parse it against Elastic common schema, and will send it across to Elasticsearch. So this is how we collect the network monitoring data. Of course, if you have endpoints, other endpoints in the network, you install packet beats on them and you ingest them directly into Elasticsearch. Now, let's say that you have a host with Snort and a host with Suricata, depending on the use case, one behind the proxy with Snort, one behind the firewall with Suricata. You can still get the data get FileBeat installed on the same host in order to collect the data, parse it against Elastic common schema, and send it to Elasticsearch. Archive, remember we talked about archive, and archive is used for capturing the PCAP file. Now, archive will store the PCAP file locally. However, it has lots of metadata that needs to be stored. Metadata, I mean the PCAP file, the correlation information, etc. These information require Elasticsearch in the background. The beauty about using Elasticsearch is that you can point archive to the same Elasticsearch deployment. So you don't need to worry about having multiple Elasticsearch deployments. So one Elasticsearch deployment, it will be used to collect data from PacketBeat, network flows, Zeek, Snort, and Suricata IDS, IPS. It will be used as a back-end storage for archive. Archive is the packet capture. So this is how they all work all together. And because Elastic, we are using beats and we are using the standard common schema, it means that one of your problems has been resolved, and that's for the correlation, to be able to correlate the data from those multiple tools. So the correlation will work fine because of that. Number two, if all those tools supports the community ID, which means that the other challenge of the correlation has been resolved. So the correlation can be done on Elasticsearch because we have all the data in Elastic common schema with community ID. That's why we can do it in Elasticsearch, and that resolves these problems. Other challenges we talked about is, for example, machine learning. Elasticsearch comes with very easy to use machine learning capability that you can use in order to tune and in order to detect anomalies and abnormal behaviors. Elastic comes with Elastic Security, so that's for the security monitoring. I will be showing you the scene now. All right, so in our demo environment, let me take you now to our demo environment and talk about the demo. So this is Kibana. This is the discovery tab. As you can see, over the last 24 hours, we have enough information generated from our box. So we have one box. The way we are having we have one box with Suricata, with Snort, with Zeek installed on top of it, with Packet Beat as well. All those with an Archime as well. So we have Archime. I know that Archime used to be called Muluk. So if you are not familiar with Archime, it has the name that have changed recently. So it's called Archime now. So it's Muluk. So it has Muluk as well. So all these tools are installed on one box. Muluk or Archime is using this Elastic instance as a backend. All the Zeek, Suricata, Snort are sending the data to this instance using beats and using Elastic-like. So there has been no custom code developed yet for the for this use case. So this is the file beat information over the past 24 hours. So this is where I told you in the event module here, we can use Suricata. You can see Suricata Zeek Snort. If we want to look at the Packet Beat information, it's a different index. This is the index name. We look at different index. Now I'll try to make this an interactive. So I will use the same window in order to show you what I want to show you. Just a note, if things went slow, I have some tabs open to back up, because you know the curse of the demo. So if we want to look at Suricata, so if we look at the Suricata information, so this is where we are selecting event module Suricata. So now it's filtering Suricata data. So now we have only Suricata data in here. What we care about, some of the fields, we care about network protocol. We want to see the network protocol. We need to see the event category. Is it a network flow? Is it an alarm? Is it an intrusion detection? We want event kind. These are the kind of information that we are interested in. So this is metric, this is event, this is alert. So these are the ones that we might need to look at. Remember I talked to you about community ID. So this is the community ID. This is the community ID that comes with the network flows that can be used in order to correlate information from Suricata with Zeek, with Archime and others. The beauty of both Elastic and the community ID is that we have developed something called scripted field. This scripted field is nothing but a link that will take us directly to somewhere else. Now, in this one, it will take us to Archime. We can always have another scripted field that will take us to the equivalent network community ID in the packet beat information. So using the community ID and scripted fields, we can make it very easy to navigate and move across multiple tools. So let's stop here. There are other tools of other fields that are of interest. For now, I'll stop here. So this is where you can look at network protocols, events, category, and the information you want. Let's say that for now we are interested only in the alerts. So if we can always filter the alerts. Now in this one, I'm doing discovery. So I'm doing data analysis. This is not the SIEM. The SIEM, it's here. So this is the SIEM when the security analysts log in to perform network security monitoring. So this is the SIEM. These are the alerts that has been detected, and these are the alerts. So these are alerts. So you can, I have a filter here. So this is where you can look at your alerts, filter them, and do investigation. That's the SIEM. What I'm showing you here now is the raw data that's generated from Suricata. So if I filter alerts, this is SSH alerts, we can look at, all right, what's wrong with this one? There is a rule, there's a field called rule category and rule. So Suricata TC rule name, the invalid checksum. So that's we can add it if we want to the, so this is how we add it to the table. So if we want, think about it, you're reading logs, but it's very easy to read the logs. So you can see it, invalid checksum, you can filter out the checksum and focus on active threat intelligence, poor IP group 66. So the poor reputation IP group 66. That's an intrusion detection. This is where we can filter this particular events and start doing investigations. If we want to do investigations, as I said, we want to look at the complete packet capture. How far is this? It should be. Archime takes a little bit until it loads the data. So that's why I was looking at the time. So we click on Archime. This takes us to Archime UI. Archime UI uses the same Elastic cluster as a backend. Here I am correlating now these information. So you see, this is the TCP dump. This is the TCP information. This is the packet. This is the complete packet. So if I want to check what is going on in the packet itself, I can look at it here. And of course, I can download the PCAP. it will download the PCAP file. Once the PCAP file downloads, you can open it using Wireshark or whatever tool you want in order to do further analysis. So you see the navigation and the correlation has been extremely easy. Now let's say that I want, and I will duplicate the tab first. Let's say that I want to do as well an analysis, and I want to see what's the equivalent in of those network community IDs in Zeek or in other tools that I have. So what we can do, we will filter network community ID, and then we will remove those filters. We don't care about the rule name. We don't know the alerts. We don't need to filter only Suricata. And let's show here the event modules. As you can see now, with the event modules, you can see that for this network community ID, these are all the events that has been generated. These are the equivalent events that has been generated from Zeek, and these are the events generated from Suricata. So if we filter the Zeek information only, we can look at the Zeek information. We can always expand and we can look at the information. What is the flow? It will show us the Zeek SSH, the decode of the protocol. It will show us information about the host. It shows us if it was an ingress or an outgress. So this is where you dig deep into this. If you still want to do further analysis and you want to look at this network community ID in packet beats, so you switch to the packet beat. And then you specify network. Again, add filter. So you can see network community ID. See, that's the beauty of using one command schema and using Elastic with supported community IDs. The great thing about using the same command schema is because that command schema will give you the information to all right, that did not show up. So that you can always use the same host name, or you can always use the right. So this is, there was a space in the previous one, that's why it did not work. So now this is, if we want, so this is where we go from the investigations. The PCAP will give us the complete picture. The what it's called, the Zeek will give us the meta information. The packet bit will give us the network flows as it has generated from the host itself. The packet bit and file bit, Suricata, Zeek, Snort. This is how we navigate across the different tools. Now let's talk about the Elastic scheme. So this is the Elastic scheme. This is where the detections are generated. As I show you, here we have lots of detections. So Elastic comes with a pre-defined detections. So you can see that there are predefined detections. I think there are now Suricata rules. So there are predefined Suricata rules that you can turn it on. This is our custom, this is a custom one that we created. So if a Suricata has detected an intrusion, we can push it towards the analyst, and the analyst will get an alert that Suricata has triggered an intrusions, and then the analyst can use it to investigate. So there's no need to look at the raw data. So this Elastic schemes, as I said, there are detections. This is the UI where you see the alerts. What we have done for the purpose of this demo is that we have prepared one of the machine learning jobs that look at unusual DNS activities. So what we did is every new DNS query, it triggers an alert. Now, of course, we can tune it. Our host is on AWS, so we can exclude all the domain names that are commonly known to be used by AWS. Now, this is one of the hosts that we did test it. We did run a couple of Bing and NSLOOKUP tests, and it generates anomalies that this DNS question name has been generated. And this is where you drill deeper. You look at the network flows, you look at the packet capture, you look at the information you want in order to do further analysis. Let me show you how does this machine learning job works. So this is the machine learning job. The machine learning job, as I said, look at the the unique DNS, the unusual DNS queries, and triggers and alerts. So if we were looking at that detection specifically, these are all the matched scenarios. If we click on this machine learning, it will take us to the machine learning job itself. So if the analyst wants to look at the anomaly, why did that anomaly trigger? Or if your team wants to investigate further on the machine learning jobs, this is where they can look at the machine learning jobs. This is called Anomaly Explorer. So this will take us to the data. And this is our host. You can always look at, identify a certain period, and then look at those anomalies, why those anomalies have been triggered, at what time have been triggered, and then you can identify a particular host name that caused you this one, for example, and then you can look at its anomaly and start your investigation, raise an incident and start your investigation. I think this is pretty much what I wanted to show you overall about the demo. Thank you for listening. Thank you for your time. I hope you find those information useful, and I'll open the forum to ask questions.
Thanks, Moz. That was a great 1 hour of informations. We learned a lot about the network community IDs, various correlations between the network security monitoring tools. Hope the session was useful for you folks as well. So we could open the forum for 5 more minutes, and let us know if you have any questions. You could unmute yourself, ask questions in a live Q&A, or you could post your questions in chat or Q&A box.
Now I can see, Haran, that you have been answering some questions. So Jitendra has asked, can you share an ideal NSM architecture? I think the one that I put in the slide is pretty much the ideal one. You need to have an IPS IDS behind the firewall. You need always to have, oh, sorry, I'm not sharing my screen. Yeah, you need to have always, so whatever, so the Zeek, the collection of the metadata information is always depending on your network structure, So depending on which link do you want to monitor, this is where you mirror the links and you implement the Zeek. This is normally happening more towards the edge switches. Snort and Suricata also, they are sitting more towards, so these network components are more sitting towards the end of the network connections toward the internet. Packet beat, things like packet beat sits on the endpoints. You don't want to implement Zeek in every network segment. So this is where you implement packet beat on the endpoints, and then you implement Zeek, Snort, Suricata, those tools more towards the internet.
Yep, and we have another question about IOCs, right? Like open IOC threat intel feeds integration with Elasticsearch. Like, yeah, Elastic also has an inbuilt modules called threat intel modules within their file beat that could help you in collecting various threat intel feeds from open source IOCs like abuse URL, abuse CH. If you have MISP instance, you can integrate with your MISP, anomalies, malware bazaar, alien vault OTX, and various things. So it's going to be a continuous growing of threat intel feeds integrated within that module. So it also has an inbuilt dashboard, and Elastic detection rules also has an indicator matching rule type where you could quickly look up into those IOCs and your host and network data and have a lookup alerts when those IOCs are matched in your environment.
Also, Elastic comes with an ingestion pipeline. So if you want to have your own threat feed enrichments, that's also is very possible to happen.
Yep. So another great question from Fang, like where are the alerts stored once they are triggered? Are they stored in a specific index? So that's right, Fang. Like alerts, all the machine learning alerts or Elastic security alerts, detection alerts get stored in a specific inbuilt index called signal. So you could utilize those indexed data to create your alert metrics dashboard, your management dashboard, CISO dashboard, reports, or even you could run machine learning on top of those alerts to understand who are your risky users, right? Which user is having a lot of alerts, or which host machine is having a lot of alerts, to understand your high risk host missions or whatever it is, right? Like you could be on top of your alert metrics. So alert is another data in a inbuilt index called signal. You can enable that in your index patterns. So Mouse, like talking about network security monitoring, right? Like when we apart from host, network datas are large in size, right? Like if you're talking about flows, there are thousands and thousands of events triggering in couple of minutes, couple of days, depending on the how chatty the network is. Like with these type of overwhelming of logs, how do you handle that in a typical architecture? And you have built your NSM on top of Elastic Stack, right? How do you feel that it is handling large sets of data sets like flows, packets,
Yeah.
IDS, IPS, and other things?
So Elastic is a scalable solution. That's one of the great things to say about it. Also, if you are using Elastic Cloud, you have the option to do an auto scaling, enable auto scaling. So if there's a network surge and there are more events generated, Elastic can auto scale in order to address this huge number of data. So that's in terms of scalability. In terms of also, you need to always make sure that you're doing the right thing with your data. What I mean is that you need always to have the right index lifecycle management. So Elastic comes with index lifecycle management. Index lifecycle management will identify when you will rotate the index and open a new shard. So you don't want to have huge indices with like terabytes of data. So it's very important to configure index lifecycle management correctly. And index lifecycle management will first of all roll out the index in order to avoid the big indices sizes. Number two, it will implement the lifecycle that I talked about earlier, where you have a hot setup, and then there's the hot setup where you have your SSD machines, and then you move it to warm. Warm, you have a hard disk, normal hard disk, and then you move it to cold. The cold is a searchable snapshot. So you start taking a snapshot, you restore one of the shards in order to do it. And then there's a frozen tier as well. So by using index, so scalability, it's scalable. There's also option to auto scale by using index lifecycle management, and by using as well the different storage tiers available with Elastic. You can easily architect and manage this huge size of data.
Awesome. Thanks, Mouse. I think like we are coming to the end of the session. Once again, thanks everyone for joining. I think we have one last question again from Fang. When the alert is triggered by the threshold or equal, will the related events trigger the alert be visible in the signal index? If not, is there any? Yeah, like it doesn't mean what type of rule it is, be it machine learning, equal, threshold, you'll have all the relevant details about that alert. For example, if it's a threshold related alerts, you will have what is the threshold metrics you have provided in the rule, which field is responsible for those threshold and everything, right? Like you'll have all these details in these alerts, be it any rule type. Doesn't matter, it's equal, threshold, query, machine learning, or whatever it is. You will have all the related informations inside your signal index relevant to those alerts. So any good resource to practice EQL? Yes, there is a playground called eqlplayground.io. So let me quickly put that link in the chat box. Just give me a sec. So our engineering team has created a public referenceable Kibana playground called EQL Playground, where it has a inbuilt sample data sets, inbuilt real-time data sets that where you could play around those equal features, right? You could create your own equals. You have various examples and various things. So this should be a very good useful use case to understand and get hands-on experience with equal. So thanks, Jitender, for bringing this up. Once again, thanks everyone for joining us. Thanks, Mos, for the great session. It was really insightful. And we do have like we are back physical meetup. Like we do have a physical meetup in Sydney on June 24th. So if you have spots, if you are available in Sydney, please jump into or visit our Elastic office, where Elastic and the SOAR platform Swim Lane will be partnering to give you a detailed important topics about the partnership as well as security meetups. So, all right. Once again, thanks everyone for joining. Thanks, Moz. It was a great session. Looking forward for more sessions together, and meet you all in next webinar. Have a
Thank you.
great, safe week.
Thanks all.
Thank you.
Always
Bye-bye.
pleasure to be here.